This course is specifically designed and developed for solution architects, system analysts and business analysts, developers, enterprise architect, project managers and above. Since we will be trying to cover in this entire course about why we need a Cloud Foundry, what is Cloud Foundry, so it is definitely useful for I'll say project managers and architects, system analysts and business analysts to understand what exactly is the Cloud Foundry. And from the developer's perspective who wanted to deep dive into the Cloud Foundry, we will be exploring multiple features and deployment strategies, ways of Cloud Foundry which is specifically meant for developers. But again, these courses initial part consists of to give you an answer about what and why, and in the remaining portion we will be trying to cover about how to use Cloud Foundry. Okay, as I mentioned earlier, that I have divided the course into two parts, where I'll be specifically just talking about serverless architecture. And in serverless architecture, I'm going to cover about what is serverless, what does it mean actually, and why exactly we need serverless architecture. I will be briefly covering how it is different as compared to your infrastructure as a service, platform as a service, and function as a service, pay-per event. Okay, so it's how different ways of infrastructure implementations we have it. What are the different ways and how where serverless fits into it. I'll be briefly talking about what are the advantages of the serverless architecture. And last but not the least, high level architecture about sample program which we will be standing up. So, so I, I just wanted to in this topic, I just wanted to tell you is that we are. I would just don't wanted to first part of the course to be restricted only towards the AWS, but then overall, I want you to understand what is serverless. Then second topic where we'll be quickly going towards more towards the AWS specific, where I will be talking about how to set up an AWS account, what is a S3 bucket, and how to set up a key in Eclipse. Since this entire implementation I'm going to do it in Java, I'll be talking about key setup in Eclipse, which plugin you need it, set up an IAM role and how to set up, and what is a AWS Lambda and how to set up actually. These are the some of the initial steps which we have to do it before we go for AWS Lambda or where we were trying to deploy our code. I will be briefly touching about the API gateway also. So beyond serverless, how you can protect your endpoints also, how the throttling works, and um, towards the end we will be talking about DynamoDB. Okay, because it really doesn't make much sense to have a service which doesn't persist any data or a user cannot retrieve any data. So we will be definitely talking about the DynamoDB also, and whatever application we are going to develop in the first part, at the end we will be integrating with DynamoDB. So I'm just briefly going to talk about Java code, but not in detail. You can prefer to have any other implementation. I'll be putting the code for this exercise in the description also, which is on the Git. So you guys can freely access it and implement it on your own. So not necessarily you do have to have a Java knowledge, but um, if you have it, it will be more meaningful how it is implemented and all. But again, as I said, it's not restricted to Java, and I'm not going to talk too much about how to implement in Java. It is just I wanted to show one way of implementation. But again, there are multiple ways you can implement the um, Lambda functions, and there are multiple packages available also. So these are the topics I am going to cover, and I hope you are going to get out of this topic what you are looking for, and um, I hope you will get almost all the information which needed for your serverless implementation. So stay tuned, and let's get started with the topic. So guys, I'm adding two more bonus topics. One is about what are the shortcomings, what are the issues with serverless architecture, because when I said that there are a lot of advantages of it, then why not everybody can use it, and why not everyone is started using it? There are certain shortcomings are there, which you should be aware before you start implementing it. And at the same time, in AWS, how the cost works, I will be talking about it. Both the topics I have added at the end of the our session, uh, because both the topics need a clear understanding and implementation uh, of Lambda function. So once you see that, then you will be yourself will be aware of what I am going to talk about it. So thank you. All right, coming to our first part, which is what is serverless. Before we get into more about what is serverless, let's try to understand the multiple infrastructure types which are available um, in currently in the industry. Okay, and which, if you are an experienced software engineer, you would have seen uh, some of these at any point of your career in software engineering. So first, and which is quite a common, is on premises. Okay, where in this kind of infrastructure type, you take care of networking, storage, server, virtualization of them. If you on the same server you are looking for multiple application and operating system, I meant is different operating types. If you are looking for, then you will go for virtualization, which is a VM. Operating systems, you take care of it, patching about them. Middleware components, like your where you wanted to run it, for example Tomcat or WebLogic or WebSphere. Okay, you take care of this. At the same time, you take care of the runtimes also. What is the actual runtime for your applications? It's like if you need a Java or do you need a .NET, those runtimes also you take care, and you start um, updating, patching, or upgrading those runtime environments. Y- Means you only manage them. At the same time, application and data definitely is yours. So what you can say that when you go for on premises, you take care of all these things. Okay, um, where from bottom of the networking all the way till application also. But when you go for infrastructure as a service, you don't take care of like virtualization, server, storage, and networking. Okay, application, data, runtime, middleware, and operating system is something you take care of it. And that is also another offering. You can see that AWS does it, Google also does it, and Amazon also does it. Most of the implementation falls into this area when somebody says that they are migrating onto the cloud, is use of EC2. If you go for AWS implementation, that's where IaaS offering comes into the picture. And another, if you go further, these are basically in the IaaS, these are some of the layers you take care, and rest of the layers somebody else is taking care of. So that's the one of the advantage, I will say, that when you go from on premises to cloud, where you don't have to take care of all these layers actually, which are not in green. Okay, but when you go further for PaaS offerings, okay, which is a platform as a service, all you do is take care, all you do is managing your application and data. Rest all is taken care by somebody else, third party vendor for you. But again, there are certain limitations, there are certain pros and cons in each infrastructure types, because you have to stick with what runtimes they are giving it, middleware, OS. You don't have a freedom in choosing these areas. So whatever is offered by that vendor, you are going to use that. So how it is relevant to our serverless architecture? So these things basically is a common practice till now, okay, but industry found it that something, if we wanted to implement quickly and easily, um, then serverless makes sense, because I add this, I don't want to take care of these layers also, okay, and I also don't want it to go for PaaS offering also. So I need to find out something, some solution where I have certain degree of control also on it, uh, but at the same time I don't need not to know uh, what are these underlying layers are there and who is taking care. I really don't care about it. I just wanted to make choose my runtime, and I wanted to where it gets executed, which platform it gets executed. I really don't care about it. So that kind of implementation I am looking for. So that's where industry went for, which is a serverless architecture. So how mostly in terms of infrastructure as a service works actually. So when you go for infrastructure as a service, you take care of VPC, then you form the subnet. Then inside the subnets, you go for your VMs, which is a EC2 instances, or in terms any kind of virtual machines which you go for in cloud. And on top of that, you start installing your middleware components, runtimes, and kind of load balancer, and then you start giving it to your end user. So that's typically an infrastructure as a service works. And as I said, how the PaaS works is basically you don't much, you take care of VPCs and subnets, and rest all is like it comes as a bundled package, like beanstalk instances, where you just have to specify like which Tomcat version you need it, and what Java version you are looking for, and that's how the PaaS works actually. So over a period of time, then industry gave a birth to a fourth way of implementing this, where which is a serverless architecture, or called paper compute. Okay, I means what exactly is the difference here is, as compared to our three infrastructure types, is you don't really know, or you don't even take care of underlying these layers, basically middleware, operating system, virtualization server, or storage, or networking. You don't even care about from where the compute power or memory is coming. All you get to choose is a runtime, okay, and you can break it into smaller pieces also, and you can then stitch them together also. So your program major bigger application, you can break it down into smaller pieces. That's something called function as a service, okay, and that kind of gave a birth to serverless architecture, where there are standalone services which your multiple applications wanted to use it, and it really need not to have much of a business data, or any much information or storage. It doesn't need it. It just tries to do some activity for any application and tries to provide the results back. Like for example, I'm just giving you is you you are you are creating a function where it does some kind of I'll say image processing, where it tries to reduce the size of the image. You create that function, and you start calling it from multiple places of your kind of, I will say, bigger application. You try to call it, and try to use it at multiple places. This is really doesn't need too much of information actually, where business context, or it's just a standalone um, function where you just wanted to use it at multiple places in the enterprise. Basically, there are certain functionality which not just you use it in the organization, there are a lot of applications use it. Like suppose if you are into credit card business, you just wanted to do the validation whether it is a valid card number. Okay, this is something can be a function as a service where not everybody has to write. You have to do the checksum and all, check it whether it is a valid number or it is a active card and all. You can have it as simple service which will just calculate, and then and there itself it will tell you that okay, this is the right card and all. So those such services you can implement as a function as a service, and that kind of in going forward it gave a birth to a serverless architecture where underlying infrastructure you really need not to know. And this how this works is basically uh, it's like wherever the compute is available in your um, VPC or in your subnet, it tries to go access those compute power or memory which is underutilized, and try to give you the results. So it is the architecture wise it is very beautiful, and it works for uh, both the vendors as well as the one who is implementing this course, implementing this architecture, basically function as a service. So how it is beneficial is for me, I don't care where it is running. So all I need is end of the day is result. Okay, and for that job how much you are paying, how much I need to pay, that's all I need to know. I need not to stand up the infrastructure or some of the things. I need not to take care of underlying this here. I have a program which I wanted to launch it, make it available, and I can completely abstract rest of the information which is irrelevant to me, and I need not to be at the same time I need not to be expert in that area. So this is how it helps, and this is how it gave a birth to the serverless architecture. Now that we know what is serverless architecture, let's see what are the advantages of serverless architecture implementation. The first and foremost important thing is reduced operational cost. Since you are not taking care of underlying layers, all you need to take care of is uh, your application, and just you need to deploy it and make it available. You don't have to worry about EC2 instance creation, operating system selections. You really don't have to take care of it, or you don't have to manage it also. Reduced development cost. Okay, so as you know that on the enterprise most of the applications gets deployed it through a CI/CD platform. You basically um, means you have a kind of pipeline which will go and deploy your enterprise application. It will package it for you, and after packaging it will try to deploy it, basically. So here what happens is when I will show you the actual practical example in terms of Lambda, you will understand that there is really not much packaging is there. Okay, on a single right click you can just deploy the application from your workspace onto a Lambda function, and you are done for the day, and it is made available to the rest of the means whomever you are giving that service available, you are making that service available to. So it reduces significantly your development cost also. Okay, scaling cost. Okay, since you don't have um, any underlying infrastructure. Okay, um, the most of the serverless implementations, um, they offer you means with certain degree of limitations, but which you don't have to worry about it. Like when I say limitations, I meant is how many requests can come actually. Okay, suppose your program is or some service you are launching it, and it's used by millions of people, you did not expect it. So in that case, in that scenario, it's not your job to manage it, that oh, it's accessed by billions of people and how I should scale it. That's no longer a headache for you. Okay, this is, I must say that this is the one of the biggest advantage I have seen in terms of serverless architecture implementation, because scaling is the biggest thing. You don't know your customers behavior a lot of time. If you are exposed externally, or you are exposing some of the service externally, then you really don't have idea about customer behavior. And moreover, there are lot of times the system is needed, or the such services are needed only during certain period of time, like festival seasons, where you see that the holiday seasons, you see that there is a large degree of access to some of your services. So such things are internally taken care by most of the vendors who have implemented serverless architecture. This is the I must say that this is the one of the important feature, advantage which serverless architecture offers. Reduce packaging and deployment cost. As I said that with the development, it reduces the packaging and deployment cost also. When I say reduce development cost, I meant is basically not too much means in terms of coding you have to do it. It's just you have to, when you go for any um, implementation, it's just you put a hook basically where your program extends some of the packages which AWS has provided, and you just put a hook around it, and like kind of starting off your program, and it starts getting executed from there. So you don't have to worry about anything. That's where I meant is development cost. You don't have to worry about like handling the how the data is coming in, how it is getting transformed into the objects. It's everything is readily available for you through the packages. You just start using it, and extend it and start using it basically. Faster to market, as operational cost is zero. Yeah, it is almost to zero. There is not much development cost is there. It's reduced significantly. You don't need to have an active CI/CD platform, but again, if you have it, it's that is good from the practice perspective. But if something you wanted to test an MVP product, I must say that this is the actual. This is something you can test it out, and before you actually spend some time onto developing a full-fledged product. Okay, and last thing is greener computing. Okay, when I say greener computing, as you have seen in my previous diagram, where I was showing you that the infrastructure drawn here is completely that information is abstracted from you. Okay, so how internally the AWS or Google or Microsoft or Oracle, they all have the serverless implementation. How they might be managing it? What they do it is, wherever the servers are underutilized, they try to carve out some compute from there. Okay, and they start running onto it. So you don't have a standing infrastructure at any point of time. That's what I meant is a greener computing. most of the time you go for PaaS or IaaS or your on-premises implementation. You have a standing up infrastructure, which is not the case in serverless architecture, where you don't know where your program is going to run, on which platform, where it is running physically. You don't really know. That's why this name came, serverless architecture, and that's what serverless architecture means. It's We can't take it literally. Of course, there is a server is underlying where your program is running, but it's completely abstracted from you, and you don't have to worry where it is working, where it is running around. So these are the advantages of serverless architecture, and I think, yeah, the um, use cases wise, we will talk into the next part. But till then, these are the advantages you need to keep in mind, actually. So now let's talk about our practical implementation, which is hands-on also, for serverless application implementation in AWS using Lambda. Okay, so this is a high-level architecture. I have not included in this diagram each and everything, but again, we will, as and when we will slowly progress, will learn, we will add. I will give you the explanation on it, and from there we will take it up. So how exactly it's going to get implemented, and this is what it shows actually. This picture depicts actually. So you have your Eclipse, okay, through which you will be pushing some code into S3 bucket. At this moment, you just have to understand that what is a S3 bucket is just a object storage. Okay, since your Lambda function is not running all the time, all all the time, it's not available for you. Okay, so it stores your code, application code, into S3 bucket, and it tries to take it from as and when needed from S3 bucket, or as and when the request comes, it brings up the code from here, it deploys on the Lambda function, and it tries to serve your client request basically. So that's the first part. You need to have it. Then you need to have a Lambda function. Okay, and further Lambda functions can be called through a CloudWatch. Basically, CloudWatch is a is a AWS offering of a kind of service where you can monitor your Lambda function. If you wanted to schedule some of the activities on your Lambda function, that also can be done through CloudWatch. And another important part is, this is about the compute part, but what about the data storage part? That we are going to do it through DynamoDB. Okay, so from Eclipse, we'll be pushing the code into the S3 bucket. From S3 bucket, it will get deployed into Lambda. Okay, Lambda will be monitored how many requests came and all through CloudWatch, and Lambda will be accessing your DynamoDB for storing and exchanging the data in between your kind of application or function to you from your database. And we are trying to expose this Lambda over the internet through an API gateway. Okay, API gateway is another external way of is actually AWS offering of a kind of service where you can protect who is accessing your service. Okay, you can put a throttling around it. You can There are a lot of other functions which API gateway provides, but we will try to have that integration where externally with a nice URL it is exposed to the outside world, which is like your any end client. So this is kind of overall architecture. Okay, there are certain pieces which I am not going to talk about, is Basically, AWS is keep on revisiting um, Lambda, okay, and the way I have seen it over 3 to 4 years of period of time, there are a lot of things they have added it. Okay, the concerns related to customer that I don't want that some data to be leaving my virtual private cloud. I want that compute to happen somewhere where my VPC is there in a particular subnets. So those things are taken care in recent past, as well as other storage devices are integrated like EFS and all. So there are a lot of advancements they have made it. But having said that, I'm for today's whatever is applicable for us for our courses. These are the components which we will be talking about, and these all are the things which we are going to do in the next uh, from here onwards. So these things we are going to implement it. So stay tuned for the next part where we will start with actually with the eclipse part, and then we will go to the AWS, and then later rest of the components in AWS. Okay, thank you. So now this is our first topic towards the hands-on, which is how to set up an AWS account. I'm not going to go too much deep into it, but just for those who are completely new to the AWS environment, I'm just giving you the starting pointers so that you can set up your account. This is something yes, I think everybody can do it on their own. But this is how I want you to start. Go on an aws.amazon.com, okay, and uh, create an AWS account. Register yourself. Amazon gives 12 months of free tier access. So you really don't have to worry for this exercise, it will be a free only. So provide your details, continue it, get the username and password, and we'll try to log in. Next process, next entire setup I will guide you through, but that's how you will be setting up your account actually. So in this topic, we will try to learn about what is S3 bucket and how to set up. So S3 bucket is nothing but an object storage. The when I say object storage, you can store your files, you can store your uh, programs, images, anything, but it is not associated with any of the VM or AC2 instance, basically. So you can be practically, you can access it over the internet from anywhere. That's where most of the time people keep their static websites also. So S3 bucket is it's a quite popular storage way in AWS. But again, there are different use cases where AWS suggests which type of storage we should be using it for what purpose. So uh, again, for our purpose, we are going to store our application code into that S3 bucket. And let's start with creating of an S3 bucket. So once you log in into the AWS console, you will land onto this console. Okay, and here you have to search for the services as an S3. So I have already some of the S3 buckets, but for our purpose, we will try to create a new S3 bucket. As I said earlier, S3 buckets are will accessible, or objects are accessible over the internet. So AWS expects that we should be writing a unique name. Okay, it should not collide with any other account holders. So we have to make sure that you are writing it a unique way so that there is nothing already existing with that name. Okay, so we will give now the name my first lambda function ever. I'm just trying to avoid any other conflict basically with any other's DNS name. It can be created in particular region. So for now we are creating in North Virginia region. You can copy the settings of any of the existing bucket also. Like we have 5 buckets, it's offering me that do you want to copy anything? So you can go for that if you wanted to. Otherwise you can leave it. Next, since it is an object storage, it can keep the multiple versions. It's not like your normal storage which works on your C drive, D drive, or any Unix drive or Linux drive, where you keep an file over there, and when you write it over there, it gets overwritten. S3 works little bit different. Since it is an object storage, it keeps the every time you update it, it keeps another copy actually in a different area. So that's all. It also maintains the versions also. Server access logging, you can log the request who has access it to the buckets also. For our purpose, let's keep the versioning. Okay, tagging is something for identification purpose. When the list starts growing it, you need to identify who is doing it what actually. And if you wanted to uniquely pull the reports also, it makes better sense to have tags added. Okay, object level logging, if you wanted to do it, it comes at an additional cost. You can do it in the cloud trail also. Okay, default encryption, since it is an publicly accessible storage, you can make sure that it is encrypted. You don't want, even if it is accessible, if somebody gets a hold of your object, you can make sure it is encrypted also. Okay, there are some more advanced settings. Okay, permanently allow objects in this bucket to be logged. If you just wanted to make sure that it is all the time access, it's just a there are no more um, objects allowed in this bucket. It's like you keep it, lock it, and have it, use it like your static website, which you don't want anybody to be coming and changing it. Okay. Next is configuration option. This is where you tell whether you wanted to make it public or uh, publicly access, or you wanted to keep it safe with protected with username and password. That's where you can you can specify these permissions. There are multiple levels, but again, I'm not going to go too much deep into it. But this is just high level that by default it is not accessible to the public. If you make it public, it will ask you, are you really aware that you wanted to make it public? Okay, for static website, definitely you will make it, but not all the time. Okay, then this is after permission, this is your review page. Let's see whether it can create it or not. Okay, since we gave a quite a big name, oh, it accepted it. My first Lambda function ever test. Okay, so this is the bucket we have created it. We are not going to update it here. We are programmatically going to update the objects into this S3 bucket. So, so this is all about S3 bucket. Again, you can play around with it, but for this tutorial purpose, this much is sufficient basically. So like again, you can change it, modify it. There are a lot of other options also into S3 bucket where you can add the life cycle also. You can like change the storage after some time if it is not getting access and all. So it works great. You can explore it, but again, for our purpose, yeah, this is sufficient actually. We have created an S3 bucket with this name, and let's go and upload the object. Let's go to our next topic where we will be learning about how to set up an eclipse. And in the eclipse we wanted to set up the um, AWS Toolkit also. So stay tuned for the next chapter. Thank you. So in this chapter, we will try to learn how to set up the Eclipse and Eclipse keys. Okay. Basically, you need mm, two things which you can download it. Um, you can download from eclipse.org Eclipse. Okay. I'll prefer a Luna. Mm, because that's all I have. That's what I have set up actually on my system. And AWS Toolkit. Actually, this is something accessible over the on the Eclipse side. So I will paste these links into is actually in the next chapter at the bottom of this chapter. But I just want you to keep in mind that install the Eclipse and install the plugin AWS Toolkit. If I'll just quickly show that also from where it has to be installed and um, how you wanted to um, download the plugin. So you can click on the link which I have given at the bottom. Go on that link, downloads, and download the version which is like you can go for Eclipse IDE for Java developers, or you can give for Eclipse IDE for Java EE developers. I'll suggest you download this one actually because it has um, J2E components also. So once you are done with that, now next comes is um, downloading the AWS toolkit. Okay, so once Eclipse is started up, you have to download the plugin, and that plugin is on this location. The URL is I have already pasted it. All you have to do is take it and drag it and drop it here. It will try to install that plugin. Once the plugin is installed, you will get this kind of view where you can access all the Amazon EC2 code deploy Lambda functions. Everything you can access it from here. Okay, so let me once you are ready, let's move on to the next topic. That's where the real fun starts begin. Okay, that's the only setup you needed. This is a one-time setup, and you don't have to do it again and again every time. So once you are set up, you are set for at least on this system for a long duration. So in this chapter, we will try to learn what is IAM role and how to set up. IAM is nothing but identity and access management. This is one of the important uh, I must say that service which AWS offers. That's where the user setups happens and all the roles, identity of the each user, what permissions they can have it. That entire setup happens into the IAM role. And how to do the setup, I'll show you in a couple of minutes. But for for our purpose, why we need an IAM is we need a user, okay, which we need to set up in our Eclipse, who will be having an access to deploy the code actually, to deploy who has an access to Lambda also, and who will be deploying the code through the Eclipse. So for that purpose, we need an IAM. So with that, let's go to the IAM basically from our console. So let's go. IAM is identity and access management. Users, add a user. Let's create a Lambda test user. So what you wanted to give an access to this user? Okay, you wanted to give just a programmatic access. Programmatic access will give you access key ID and secret access key. Okay, so that you can access it from your Eclipse. You don't need to give the console access to this user because this is a programmatical. This user is going to access your application through programmatically. So next is, let's see. So let's see what permissions we have to set up. Okay. So set the permission, create without a permissions boundary for now. Okay. As I said, I have a habit of creating the tags, and let's create it. At the organization level, a lot of people will be working, so it is a best practice to have your tagging properly. There are a lot of advantages of having tagging. You can identify the application, billing, resource groups. I know those are not relevant for this topic, but tagging is one of the important thing, and you should enforce tagging most of the places as an organization. So, okay, the users have no permissions. I think we have to go back and permission boundary is not set up. So let's see, create a group, add a user to the group, or attach existing policies. We'll give this user a Lambda access. Okay, this shows AWS code deploy, AWS Lambda basic execution rule, or we can give a Lambda full access. For this purpose, we will give. So again, you want to refine the access for that user, you can do it. If you don't wanted him to deploy or something, so that also you can do it. I went to the existing attached policy, tags I have already created, review, AWS Lambda full access, create the user. Okay. Once the user is created, it will show you some of the details which you can copy it, and we can go here in Eclipse, preferences, AWS Toolkit, and you can copy your usernames and passwords here basically. Access key and secret access key here. Once you are done with that, then we can take our next step. Okay. Now in this chapter, we'll try to learn what is the AWS Lambda and how to set up. In the how to set up, I'll be a little bit talking about the code also, and how we can deploy it into the AWS Lambda. AWS Lambda is, as I stated earlier, it's an implementation of serverless architecture uh, by AWS, and that's what they call it, Lambda. Multiple vendors who offers the cloud services calls it with a different name, but underlying the concept and architecture is serverless. So let's get started with our Eclipse setup, how we can deploy our code. I'll quickly walk you through, guys, through some of the code also. So now I'm back to with your Eclipse. In the Eclipse, I have created basically three packages, which are main packages for our purpose. So for our so now we are in Eclipse. For this hands-on exercise, I have created three packages. Okay, first package is com.sachin.lambda, which is just a simple lambda function which we will execute. It doesn't store any data, but it will just say hi. It will return a message. Second one is with DynamoDB, and there are supporting beans actually, which I have kept it into this. Um, this package actually. So what exactly we are doing it into Lambda request stream handler. Okay, we have um, we have imported the AWS SDK. Okay, so this one something you have to download it, which will be yeah. So which After downloading, you will be able to import these classes. I'm keeping this code into um, Git also. I will provide the link at the bottom of this session. So what we you can just download, set up the Eclipse, or I'm also creating a package which you can use it. Okay, which you can just deploy it. You don't need to go for this Eclipse setup also. If you wanted to skip it, that is perfectly fine. For those who are interested, they can go ahead. So here I have created imported two classes, which are Amazon classes, and here is what I am doing it. Okay, one Lambda request stream handler, I have written it, and I am implementing this interface which is provided by Lambda. Sorry, by AWS. Okay, com.aws. This is the package which we are having it. Okay, so this one comes from this basically AWS SDK. So what I'm doing is I'm overriding this method where I'm just writing it onto the output stream. Hello all, this is my first serverless program. Okay, and I'm just trying to push it onto the output stream, and I will get to know what exactly it is. In return, I am getting it also. Like it's a post request. Okay, so let's try to deploy this method into Lambda. Uh, Lambda, which is in AWS. We have done the secret key and all setup. Now we have to do deploy it. Okay, upload the function to Lambda. Okay, you can run the function on Lambda also from your local machine. That we will come later, but before that, let's upload the function to AWS Lambda also. So it is asking me what should be the select the handler name. I was talking very initially about certain hooks you put it. It will by default try to identify which are the main programs, which are the starting programs which needs to be used. So as I said, I am just at this moment we will first test it out the our simple hello all program, and later we will go for our second program where we will be deploying the DynamoDB also. Okay, I am giving the name to this Lambda function as a my function or my hello function. Since I gave the credential, it is downloading all my details here. Okay, from our AWS account. So here you can see that this was something, if you remember, this something S3 bucket we have created. You can create the S3 buckets from here. Okay, this is another option. From here, you can create your own S3 bucket. Okay, I just wanted to give an overview of S3, so I have that's why I went to the console and I tried to do it. Okay, this is my first Lambda function. So I am trying to either use this role, which is an existing, or I can create a new role. Okay, for this function, role is nothing but what level of permissions it has, what it is going to do it. Um, Basic IAM role that allows Lambda function to call AWS services on your behalf. Okay, so let's create a new role. Okay, let's see what happens. Okay, if you remember, for the user which we configured in Eclipse, we only gave an access to only to Lambda basically. We did not give it to access to rest of the places. Try to have your program or the user setup in such a way where they have limited access to the areas which they are really needed. Okay, IAM is a something critical area, so you should not give too much open access into IAM area. So This is one way of restricting to the developers or anybody in the program who should have, that what level of access you need it. You can provide the access. You have already also seen that Lambda also has a restrictive level of access, and for now I have given the full access. Okay, so let's pick up which is an existing IAM role. We will see what happens with that. I also don't know. Okay, at this moment, and I am giving the memory as a 512 and 15 timeout 15. If it is does not get executed in 15 minutes, give me an it will give you an error. Okay, let's see whether it deploys or not. Okay, so looks like we are lucky. Okay, and let's go and in the console and let's go and check whether it deployed our Lambda function or not. Okay, see, we have deployed my hello function onto Lambda. Okay, it deployed it. Okay, and it's too large, no tags. This was the description we have added. Com, okay, timeout 15. All our enter setting came here, so which we did it through our Eclipse. Okay, so you can set up the VPC and all later, but let's see. Step by step, we will take it up. Okay, in this video, what we will try to do is whatever function we have uploaded in during our last session through Eclipse, we'll try to test that. Okay, some kind of unit test on the server. So let's see. Let's do hello world test. Our program does not expect any input. Okay, this is just by default template which AWS it provides for you. We don't need it, but again, that is the most closest I find it, and by default, that's what it is offered. So with that, let's go and create it. Once we created it, let's see whether our program runs or not. Okay, let's hope it runs successfully. And all right, it ran it without any issues. So what was the output we were giving? Hello all, this is my first serverless program. So we have successfully deployed our program and ran it also. So hello all, this is my first serverless program. If you wanted to do the second, we can do that also, but we need to re-upload our program over there. So AWS upload function, choose an existing my hello function because last time we did my first Lambda ever test. Let's see whether it gets deployed. It's taking time because it is making the connections and all. Now let's see whether it deployed on hello world program. We this time did second we made a change actually on our program. Let's see whether it got deployed or not. It will tell you when it deployed last time. Maximum range of an event, retry attempt 2, my functions, we can go back. So our new program is already deployed. That is a 41 seconds ago. Go here, let's try to run it, test, execution. This is my second serverless program. Voila, we are good. So here we have, this is what we have done it. Small program, we wrote it in Eclipse, deployed it through Eclipse, ran it here and tested it out. Okay. we can test it locally also, which we will show you when we are actually trying to deploy DynamoDB also with our application, where we will be testing it locally also. So let's meet in next chapter where we will be talking about DynamoDB. In this chapter, we will try to understand what is DynamoDB and how to set up in AWS console. So before that, I just wanted to give a brief overview of what is DynamoDB. DynamoDB is a fully managed proprietary NoSQL database. So it supports key value and document data structure. This is a proprietary, as I said, Amazon's product, which is offered to AWS customers. Now let us come back to our program. Okay, what it will try to do is it will try to store information about me, okay, into DynamoDB. So DynamoDB is what we are doing is we are same class we are extending here. We are telling that this is the table exists in DynamoDB in this region, okay, and locally how we can test it out, I am trying to show you guys also. Okay, so in this program what I'm doing is I'm going to make a connection to the DynamoDB, and we will start inserting the data also, and we'll test it out that later. Okay, so but programmatically what we are trying to do it is we are trying to insert some of the data into DynamoDB using main program, at the same time through our handle request, which is nothing but a Lambda function. And what we are doing is we are trying to get after persisting the data, we are trying to get a response also, saying that saved the record without any issues and successfully. That's what this program is trying to do it. Okay, so let's quickly jump onto DynamoDB and try to explore more in terms of what exactly is the DynamoDB. So this is the DynamoDB console. You can search it from here, DynamoDB. It will take you manage a NoSQL database. Okay, it will bring you to this screen. Create a table. We wanted to create a table by name person with ID, and if you would have noticed, I have created an ID of type number. In the program, I am expecting this to be a type of number, basically set ID. I'm not using it as a string. If I would have been using it as a string, I would have done it, kept it in the table designing also in the similar way. Okay, and I'm handling it as a numeric number. So since you can see that it is an integration. So now if I go back here, let's try to create a table with default settings. Okay, default setting means no secondary indexes, and provisioned capacity is set to 5 reads and 5 writes. So again, this is NoSQL database which is offered by AWS and which is open, means which we can access it over the internet also. Okay? And or you can make it more secure also. So let's create it simplistically, then we will revisit its some of its attributes actually. So now that this table is created, it has some more features actually which you can enable it, like recovery time, encryption, since it is exposed, okay, over the internet it is accessible. So you can, there are a lot more settings, but for our purpose um, we are not trying to do much here. All we are trying to do it is created a person table with an primary key as an ID. Okay, rest we will see as we progress. Now we have in this account we have created a person table. Let's try to insert it some data from our program basically. Okay, so in this program what we are trying to do is we are trying to run it as a main program and trying to see whether we can push it the data into DynamoDB. Okay, so let's see whether it successfully. It looks like that it successfully inserted the data. What happens is I'm trying to print the data what we am pushing it, and looks like it printed it. It saved it, and that's what we got a response actually. So set message. This is something we are not seeing it, which we will see it in the DynamoDB. When we will go for our Lambda function implementation. So let's quickly go to our table and see if data came here. And here you go. Your data successfully landed into the DynamoDB. And you can see that everything is here. Right? So now you have tested your application that it works. Now we wanted to deploy the same thing into Lambda. Let's upload the function. Do you want to we can overload also the same function. Okay, but this time we are telling that this will uh, this will be using as a this handler but not this handler. Okay, so we can go for this handler. Okay, in the east region. Next, it is pushing our program. We wanted to use this S3 bucket. This is my DynamoDB Lambda function. Let's finish it. Let's see whether it uploaded or not. Go to the console. Go to the Lambda. And let's see whether it uploaded or not. 11 seconds ago. So we are sure that it is our program. And this was the description which I gave it. So now here what we are doing is, in this function is, we are telling that this is the handler. While in the earlier program we had a different handler. So now this program expects us to pass this object to the handle request. Okay, and this object is nothing but a request which is coming from your test program, where you will be pushing ID, first name, last name, age, and address to this into this object, and that object will push that data into DynamoDB. So let's see how far we can go with this. So let's configure a new test event. Hello world. Now you can see that I have already created one event. Okay, with these details, saved it. And let's try to test it out like we did it last time. Now, so what did happen? It is saying that this role does not have is not authorized to perform this action. So we did one mistake actually. When we promoted this program into AWS, we chose the wrong security group. Let's see. My hello function. Next. Then here we chose the wrong IAM role, which we wanted to choose it here. So let's deploy it once again. Let's go back here Let's refresh it and let's see whether our program 13 seconds deployed. Let's test it out once again. Executing the function. Hopefully this time it will run. We can go and check into DynamoDB. It does not look like it inserted the data. Okay. My hello function is not authorized to perform DynamoDB. That is another problem, because when we created this user, we did not give permissions um, other than Lambda. So let's give the permissions to this more than what we have initially thought about it. So let's go to IAM. Lambda basic execution rule. Attach policies. Here we will attach the policies related to Lambda. Let's give the Lambda full access. But again, it's based on your need. You can specify what exactly you wanted to do it. Now we have attached the policy to this role, which is a simply Lambda role. I hope we have saved it. Hopefully we should be good. Let's test it out once more. And here we go. We have successfully saved the record without any issues and successfully. And let's see whether it updated in DynamoDB to India 12 anything about. So now you have learned how to test your function locally from your Eclipse. You know how to test your function by making a connection to the DynamoDB. Push the data from your sample program using a unit test case. Now in the next chapter, we will see how to expose this APIs through API gateway. So till then, stay tuned and let's see. So far we have seen integrating your Lambda function with DynamoDB, standalone running of DynamoDB, as well as unit testing into AWS console itself. Your program, you have done it. Now what you wanted to do it is, we wanted to expose this service to the external world, and in a secure way. That also in a secure way we wanted to do it. So what we are going to do it is, we are going to make use of API gateway. So let's get started. What exactly is the API gateway and how to integrate it with AWS Lambda. So as I said, we will be learning how to integrate with AWS Lambda, how to call the method from API gateway, AWS Lambda method. Let's search for API gateway. API gateway screen looks like something like this, and what we will try to do here is we try to build a REST API. New API we'll try to build is save for some detail test regional. You can have it available as an age optimized also, or you can make it a regional also. create an API. Okay, you wanted to create a method also you wanted to create. So what we are going to do is post basically. We are trying to integrate it with Lambda function. Our Lambda function, if you type it here, should come my hello function. Save it. Okay, this is giving the permission, gave, and here we have integrated with our Lambda function. So let's go back to Lambda and try to copy the call. Let's say calling JSON object. I don't want it to rewrite it. Let's go to the API gateway. Let's test it out. Request body. Come on. Here, this time we will have it 3. We will test it out. Let's see whether it is working or not. Post. Yep, we have saved that record without any issues, which is the third record we saved it. Okay. So now we have integrated with API gateway also. Now what we have done so far is we have done the integration. Now we wanted to deploy it. Okay, deploy this API so that we have a nice beautiful URL. Prod. I'm just giving the stage name where it is getting deployed. Okay, so now it gave me a nice URL. This URL I can call it from anywhere. If I want to protect it, I can protect this URL also from wherever it is getting called. At the same time, I can make sure that it is somebody is not misusing it or sending a huge number of data. So I can throttle also around it. I can burst requests. I can number of requests it can accept in short period of time. That also I am specifying it. If you see now, I have a infinite capacity. Okay, for my program, I can push as much data I wanted because my DynamoDB is also scalable as well as my Lambda function is also scalable. I'm not going to go into each one of this setting, but again, if you want, you can go ahead and test it out. So this is something I wanted to show you, throttling and all. Again, you can create the API keys for your security purpose. Usage plan, you can give it for multiple clients. If you wanted to have this service used by 4 or 5 teams and you wanted to see who is using more, you can track it also. Or you wanted to give some licensing like 100 requests. After that we will not be accepting any of your requests. You need to request us that more licenses are needed or more number of executions we need it. So that all you can configure it through API gateway. So now you have a nice API gateway URL also. You can store the data also. Okay, if this is a post request, so I can directly go and test it out in the browser because it is gonna say that missing authentication token. So you can test it through any one of the any like SOAP UI or anything. It is a REST. Have a JSON object created the way I have showed you and test it out. So and you can push the data as much as you want it. So now we have covered the API gateway also. So let's see in the next chapter about what are the disadvantage of what are the I mean shortcomings, not disadvantage. I will say that shortcomings are which Lambda function has it, and I will try to we will try to go through each one of them, and later we will see at the end as a billing reports. Now let us try to come to our last two topics, which are kind of bonus topics, which I have added later, is about shortcomings of serverless architecture. As so far you have seen that it has how quickly you can go into Lambda as well as DynamoDB, start pushing your data and make that service available over the internet also. So you have seen all those actually integration points as well as how quickly we made it available over the internet. And it has a lot of advantages also, because um, you have unit tested, deployed, which is not that much easy on any platform or anywhere we try to do it. But if there are so many advantages, one can ask why not everybody started implementing it. There are certain use cases for which it is not suggestible, and there are certain shortcomings serverless architecture also has it. I kept that as shortcomings as a serverless architecture because it applies it no matter which vendor you go for. So these are because the architecture it is residing on, um, it has certain, um, I must say that there are certain shortcomings which you will see everywhere. First is vendor control. As you can see that there are very limited options which we can do it into the serverless architecture in the Lambda, actually in AWS, which we have seen it. Like what languages we can select, what version we can select. So there are mm, limited versions available. We can't just go for any version and try to deploy it. So most of the control is under with vendor. Loss of server optimization. Okay. Um, as you can see that there's nothing we can do much for your program. Like if you try to improve its performance or any optimization you are trying to do it, you really don't have a control on it. Execution duration. This is something it varies from time to time. Okay, if you would have observed it, you try running your program multiple times on a gap of like 5 to 10 minutes, you will observe that the execution duration is different. Okay, and if after a gap if you try to run it, there is a latency also, that is called startup latency. As I mentioned very initially that mm, not all the AWS Lambda which you try to implement is all the time it is running. Okay, it runs as and when there are certain request comes onto that their way. Okay, so how it works basically is first request when it comes, it keeps running that server for some time or that container for some time, so that consecutive requests are served without building the container. Okay, but if you give certain time, basically like 10 minutes or 20 minutes if you give and you try to execute it, you will see that first request is taking time. Okay, so why it is taking time is because it is taking the data from S3 bucket, data in the sense your program trying to find a container and deploy it onto it. So that makes it a little bit of difficult for certain initial request. Okay, if you are running a large programs, then you might experience it. It will be so obvious for you. So that is another problem. Debugging. So you have the debugging is a little bit limited, as you have seen it. Like if you would be doing it on your EC2 deployment or anywhere else, you would have went to the console and just started printing some of the statements and started looking at it. Debugging, it takes little bit of time. Okay, monitoring and observability. Okay, so since this is entirely under vendor, um, whichever cloud vendor you went for, so it's a little bit of difficult to monitor how our program is performing. Is there any memory loss is there? Okay, like um, any objects are consuming more memory. Okay, so those things we won't be able to find out very easily in the um, at least wherever you see the serverless implementation. So these are the some of the shortcomings, and when you're designing any solution, considering the Lambda function or serverless architecture, you need to consider this, that these will be your limitations. And if you wanted to, if you feel that you're not comfortable with this limitations, then I, I will suggest that Lambda function is not the perfect candidate for you. So let's meet in next chapter where we will try to see how the paper compute works actually. So stay tuned. So this is the last topic, guys. So in this topic, what we will try to understand is why it is so cheap and how it is the calculation is done basically. So this is from AWS actually. Okay, what it says is if you have a program of 512 MB which is executed 3 million times in 1 month and it ran for 1 second each time, your charges will be calculated as follows. So basically these are the things you need to consider when your program is running, when you are deploying it onto Lambda. First is, what is the memory allocated, how many number of requests, and how much time it is running. Okay, I know that latency is there for the startup, but that is you are paying for it. Okay, so your monthly charges are like these. This is per I'll say per GBS, and the free tier has some 4000 GBS actually. That's how they calculate it. Okay, so total compute is 3 million requests are there into 1 second, which is the one execution cost around, which comes to around 3 million seconds. Okay, and total compute is in GBS. Okay, GBS is nothing but how many executions per uh, GB. Okay, so you have seen 512 is converted into GB. Okay, and 3000 seconds are there. You're multiplying 150000 GBS is your total compute. So you have every month they give you during free tier these many number of requests actually. So here we are subtracting it, and you are paying for this much only basically. Free tier is after your free tier is gone, you're paying for this much, which comes the cost wise is totally $18. If you are running with some application of this size for this much, it's a 3 million. Okay, GBS is like kind of their way of compute. GB memory, how many seconds basically it is going to run. So that's how the entire cost is calculated. So you can see that if some application you wanted to launch for a 3 million request, what kind of infrastructure you need it. Okay, and how cheap it is. So that's why it is quite popular. And if you wanted to run something ad hoc or some batch processing, I don't see why not actually. Any function as a service you can implement into Lambda, and it's very much cost effective. And I don't see anybody why anybody should not go for it. But again, consider those limitations and think on it. So with that, thank you very much, and please, if you guys have any questions, please feel free to put it in a comment section so that I can go through it, and I can start answering it also. And if anybody wants to reach out to me, you can visit my website also, which I already told, http sachinkapai.com. At the same time, you guys can visit me on LinkedIn also in case of any questions. So thank you very much, and please do leave feedback. I'm Most of the time I try to give these courses at without any charges. So to improve myself and spread the knowledge across the community, which I have learned today, which I would have learned it in a difficult way, but I believe in spreading the knowledge. So please go ahead and subscribe, leave a comment, and tell me what I can improve more. So with that, thank you very much.
Hello, friends. Welcome to another topic at Learn IT in 5 minutes. Today, we are going to talk about what is blue green deployment.
All right, let us try to understand what is a blue-green deployment in detail. So typically when you have a web-based application, you configure your DNS. For example, consider you wanted to update this website www.sachinkapai.com, which typically routes the traffic to through the load balancer to one set of stack with a particular version. Okay, when I say stack, it consists of application release version 1.0, app server is of version 1, and database server is of version 1. For this set of for this release of application, so when you wanted to do any new release basically, and you wanted to publish a new set of functionality to your end user, typically what you do is you make those updates to the existing environment, like you do the release. Okay, 1.1 app server, you are upgrading it here, it is like 2, and database you are updating it to 1.1. And during this entire period, what you do it is you disconnect the traffic coming into the system while you are doing all these activities, and users are either shown a sorry page saying that sorry, you can't come into the system, we have a downtime. So this is how typical releases works. This is how typically you do your all your release, app server upgrades, database server upgrades. So that's the model. Most of the places you are following up. But what exactly different happens in the blue-green deployment? In the blue-green deployment, whatever upgrades you wanted to make, you stand up a parallel environment. You stand up a parallel environment with whatever set of um, updates you need it, like release 1.1, app server 2, database 1.1, and once the environment is stood up, what you do is you test it out this environment. Okay, you can test it out standalone on a different URL, which is the internal, which is not published to the end users. Okay, and once that verification is done, you connect that the URL, or you configure as a pool for your load balancer, and you start sending the traffic to this newly created stack. And slowly what you do, once it is verified everything is fine, you do is you start disconnecting this blue environment from your load balancer. So during entire this process, the end user never gets affected. They don't even notice that they are continue to use this URL, and they continues to basically access this website without any issues, and they don't realize that their entire traffic is routed from earlier version to the new version. The only advantage of this approach is your end users are never impacted. There is zero downtime basically, and there is no possibility of going anything wrong, um, because you are already standing up the environment and you are testing it out. So that's the biggest advantage. The only disadvantage, you are parallelly standing up the two environments for a certain period of time of your testing. That's the only disadvantage in the blue green deployment. Otherwise it's a very well proven model. If you have a um, infrastructure which is elastic enough to have you can stand up a parallel environment for some time, um, then that will be this will be your best approach, and this is how you should be releasing your application. So thank you very much, and please do let me know in case of any more question, and please subscribe to my channel Learn IT in less than 5 minutes. So